the other potatoes. Therefore, when we are talking about food security, OFSP is very, very important from regarding food security. And then particularly on food security, gender issues have become key in agricultural research and activities, mostly focusing on the differences between sexes in production. Besides, men and women may have different agricultural production functions, possibly influenced by sociocultural norms, so that the gender differential and participation along the OFSP value chain is very vital in modern research as it impacts adoption and diffusion of technology and outputs. And so we are hypothesizing that gender may significantly impact the success of adoption and diffusion of OFSP, and we have 3 objectives: to analyze the gender differences in roles and activities in OFSP production, to assess gender constraints in the adoption and diffusion of orange flesh sweet potato, and to conduct gender analysis in the socio-cultural and economic factors that inform adoption and diffusion. This is a method we are looking at all.
5 minutes,
we are looking at all the sweet potato growing areas, because I know most of our activities have been there as an institute, and then we will use a multi-stage sampling procedure. In all, we are looking at having 180 farmers and city traders as a sample across the study areas to work with. The data tools will be using questionnaire, focus group discussions, and key informant interviews. And also, the data analysis will do some descriptives and inferentials, and then the qualitative will look at content and thematic analysis. These are expected outputs, and we are hoping that we'll be able to come out with strategies to liquidate the cultural factors that inhibit gender participation in our activities. So these are my communications, and thank you for your attention.
Shall we therefore? Thank you very much, Mary. We've saved us a few minutes. Can we go to invite Dr. Patricia Chapo to give the next presentation? Thank you. The platform that she comes. My former Fuji. Shall Dr. Jenna Sedu, please, I give your presentation as they work on it. Shall we give you a clap? So that you have 10 minutes, please.
Thank you, Chairman. I'm Jonas Sosé, presenting work done for 2020 and plan activities for 2021. For 2020, my work was basically in two folds. That is project activities, in terms of project management and coordination, then administrative duties. With regards to project activities, I was the coordinator for the CORAF Partnership for Agricultural Research Education Development Project. And this project is basically on how best we can disseminate improved technologies from maize, making sure that we can have a vibrant seed system as well as improved practices. And it's being led by CORAF within 5 countries, of which crop research is part of it, and then we have CSIR in the northern sector. My next activity that I actually contributed was the MAC project, and I was the focal person for the innovation platform component. I also did work as a technical advisor for the Skills Development Fund project on post-harvest management. And this was basically how best we can develop training materials to organize short-term trainings so that people can get to know what we do as well as generate some income for the institute. I also coordinated the Agriculture Project Technology Center, which is basically focused on how best we can partner with the private sector to make sure that our technologies get to the private sector and becomes beneficial. In terms of administrative duties, I was the chairman for the Junior and Senior Staff Promotion Committee. Then through our work as a committee, a lot of our junior staff and senior staff were promoted. I was also appointed the general manager for CSIR, and then I did act as head of division of 2 occasions, as well as a member of 2 committees for the RSA. So in terms of highlights, as far as the PEC project is concerned, a lot has been achieved. We started in March 2020, and in terms of highlights of achievements, I would like to say that 8 community innovation platforms were established in 2020. And as we speak, we've scaled it to 12. And out of these innovation platforms, we were able to lend 2 of them to a financial institution. They were able to get credit to the tune of 43,000 Ghana cedi. We were also able to support 5 seed growers, that is certified seed, to produce seed for our farmers. In terms of technology dissemination fields, 6 were established at community levels where improved variety and other practices were demonstrated, and this was led by Dr. Stephen Yaboa. We've also developed about 6 different types of dissemination materials, which we hope to distribute to farmers this year. So this is a picture of one of the innovation platform sessions we had, and this one also field day at Wenchi Municipal, and this was the signing session for the loan agreement, which we facilitated. We are not part to the contract. Under the MAP project, as I said, I was the focal person for the innovation platform, and we undertook needs assessment for 5 community IPs that we work on, and that helped us in coming up with work plans for 2020, which were successfully executed. One thing we've realized is that once you establish innovation platforms, most often than not, when the project ends, it also terminates. So what we're trying to do under the MAP is to establish an effective governance structure, such that with or without the projects, these IPs can still continue, and that was effectively done. We also supported some of the IPs in terms of capacity building, basically in seed production. So we undertook some capacity building in yam seed production as well as rice. We also had stakeholder meeting, which brought together different partners from NBS, CSIR, BCR, and traders and other people to discuss how best we can work together as an IP. As far as my work is concerned at the Center for Agricultural Productivity, we have a number of training models that we intend to roll out this year. And one of the ideas that came up was that can we think of going online especially with the current pandemic that we're facing. So we had discussions with an IT firm known as Active 8. And through that, a partnership agreement was signed, and we are on our way to roll out online training programs. And this picture shows some of the discussions we had with the director and some lead facilitators. As far as CRI TV is concerned, we've established our management team, and we were successful in covering some major activities during the year. Permit me to say that we were successful in covering the CCST graduation ceremony, which was highly accorded. We were also able to cover the Mercury AMF virtual workshop, which was organized by Prof. Demoku, the 31st Delegates Annual General Meeting, as well as the Commercialization Award. We also did roll out a number of programs. One was the project, which director was the first guest of the show, hosted by my good self. We are grateful for his appearance. We've also aired the first edition of Women of Science, which featured Professor Mariam Kwe, and we are grateful to her. And we've also shown our first weekly news on CRI TV. And as we speak, we are covering live this event. So these are some of the pictures of some of the events that were carried on CRI TV. In terms of our coverage, we started around June, July, and I must say by December, we had about 2,723 people visiting our site. And in terms of number of times they visited, it was about 4,700. Some visited once, some visited twice, and that kind of thing. In terms of hits, about 591,000 plus. So that tells you that people are actually following whatever we do. We need to carry on.
You have 3 moments.
Okay, so for 2021, I intend to continue as far as the PEG project is concerned. We will be working on standardization, which has come up strongly. We will also be distributing the training materials that we have developed. We hope to produce a video documentary on improved maize production and entrepreneurship. And then we're going to have training for the seed growers so that we can be sure of sustainability. Under MARC, we will continue with our activities. We basically establish some innovation platform specific topics in terms of seed production. Because one of the major things we've realized is that we have a very big seed system as far as all the crops are concerned. And we're trying to use the innovation platforms to see how best we can contribute in strengthening the seed system. As far as the APT is concerned, we will be rolling out the online training program. And we hope that this will help us to be able to generate some income for the institute. We also want to organize physical training programs. Beyond the online, there will also be some training programs going on at the center. We started a project on how best we can have a voice SMS alert system so that by the power of a mobile phone, farmers and other clients can have information on our technologies. That project stalled on the way, and we hope to complete it this year. So, as far as the ICRA project is concerned, this is a new project by Dr. Yeboah. I'll be contributing in terms of conducting a study on willingness to adapt today. I will also be helping as far as stakeholder engagement is concerned in establishment of innovation platforms. They have also expressed interest to be part of the voice SMS alert system, and then we'll work together to see how best we can integrate them into the system. CRIT activities will continue. We focus on how we can mobilize resource in terms of personnel and equipment. As you can see, sometimes the feed goes off because we have internet challenge and other things. In terms of cameras and all that, we need powerful cameras that can last. We will also roll out some innovative programs like the CRI Kitchen, the community, and then others. We want to expand our coverage to go beyond that CRI and also other programs. And these are the list of my publications.
You should have come earlier. Thank you very much. Shall we give me a clap? Thank you, sir. Shall we now invite Dr. Rosida? Shall we give me a clap in the next case? Dr. Rosida. I thought my Eric is missing. Eric, you have 10 minutes.
Thank you, Chair. Good afternoon to everybody. So my name is Eric Obusukamfa. I am an agronomist and cropping systems expert with the ICM Socioeconomics Division. So this will be an outline of my presentation. I must start by saying that I'm grateful to the Almighty God that by the year 2020, the major activity I engaged in was writing of my thesis, and by God's grace, I completed and also completed my PhD at the Michigan State University. So this is a huge success story. But let me share with you some of my major findings which I used in the writing of my proposal. So the study was on pigeon pea white yam cropping systems for improved productivity and livelihood of smallholder farmers. The major issue with yam production is sustaining soil fertility and also getting stakes for yams to climb on. And these are very important and they affect productivity. So pigeon pea, which is a legume and at the same time a shrub, is able to fix atmospheric nitrogen, and it also has stems which can be used as live stake or it can be cut and used as stakes. So I did these two studies at Edra and also here at Comisa. And I must say I started with a socioeconomic survey where I looked at farmers' perception of the pigeon pea and how they were willing to integrate. They were happy to integrate, but of course, they mentioned that most of the farmers indicated they didn't know this plant. There was therefore the need to involve farmers to make sure that it's a participatory study. So right at the beginning, at planting, at vegetative, and also at harvest, I involve farmers in this study. So this is the main results at the field. It can be observed that when you plant pigeon pea in alleys and cultivate yams within, and use half recommended fertilizer, you are getting yields which are similar to if you had used full fertilizer rates with the introduction of the pigeon pea. And it can also be observed that when the farmer has no money for fertilizer, the introduction of the pigeon pea alone made improvement in yields when you look at when the fertilizer were applied. And this is for both locations and also for the 2 seasons that the study were conducted. So the pigeon pea yam cropping system in terms of productivity did make some gains, and farmers were happy when we had farmers field days. But every technology comes with challenges. So the major challenge we encountered with our interaction with farmers was the 8 to 12 months period needed for the establishment of the pigeon pea to be able to get the biomass and the stakes and the others were such a challenge for them. They cannot wait for that period. So upon reading literature and pondering, I realized fast-growing legumes such as cowpea, bambara granite, soybean, and others granite can be grown during this lag phase. But there is the need to go to the farmers and to talk to them. Maybe they can also have their side of the story. So I went to them again, we spoke at length, and they were willing to plant, and they even indicated they are already into this cultivation of these fast-growing legumes. But as you can see with this diagram, my ultimate goal is that yam production should be profitable to yam farmers, not only in Ghana, but to the whole of the West Africa yam belt. And this can be achieved by making sure yam farmers reduce their cost of production, they use inputs efficiently, and also adapt good crop management practices, which this pigeon pea yam cropping system seeks to bring in. But of course, to address the problem of the 8 to 12 months, which we are thinking of, I'm thinking of introducing the fast-growing legumes. There are some R&D aspects that I have to work on. So the above and below ground interaction of these fast-growing legumes and the pigeon pea needs to be studied. There is also the need to study the end fixation and the end contribution from these fast-growing legumes in the pigeon pea yam cropping system, and also to look at the profitability if we should introduce these fast-growing legumes into the pigeon pea yam cropping system. And this is something that will engage me for the few years ahead. I need to get funds, but I've written some proposals, some are gone, and I'm still working on others to be able to get funding to be able to do this. So 2021, I'll still be working on proposals. So I'll continue with to encourage proposal writing and manuscript writing. This is a special task given to me by my former HOD and my current HOD to make sure I do that at the divisional level every Friday, which I am working on. And also I will continue to collaborate with other scientists and other relevant institutions to work on funding to be able to get money to work. I also continue to prepare manuscripts and also assist in peer reviewing of scientific papers. These are my publications for the year under review. Thank you very much.
Shall we give him a big applause? We see that from me. Thank you very much, Eric. Thank you. We shall now invite ladies. The 6 ladies are called. Yeah, May. Let's do those claps together, she comes. May, 10 minutes for you.
So I'm Mary Sapo, and I'm in the Resource and Crop Management Division. These are the work that I did in 2020. First of them is I did a training with some farmers at a school in the Eastern region. So I trained them in the new technology, and then set up a demonstration field for them to see how it's performed. I also did a fertilization application trial on station here on the aeroponic generated CDR to look at the right fertilization rates for the CDR. And then I also worked with the team on the verification of weed management trial in rice and maize in the Ashanti region as part of my program. And then finally, as the assistant coordinator for the Institute Mentoring program, we together with the main coordinator, we organized our 6-month progress presentation, and the aim of this is for the pair to share their achievement and also to know what went well and what didn't go well in the relationship. For 2021, I'll first be working on the project we co-wrote with Arusha Ghana, an environmental NGO on climate change and the consumption landscape, and it has been accepted. So we are yet to start it. And then I'll also be working on IFSA 2 project on this aeroponic generated CDR to look at how it performs against the farmer safe seed. And we will look at some basic crop management in yam, such as milking and different pesticide and then different size range of the set. And also time of planting for the CDR. So, by way of introduction for the climate change project has been concentrated. Recently, the community around the lake has been reporting of less predictable rainfall and more drought, and then even when the rain comes, it comes with such a destructive torrent that it destroys their crops. So, and we will also have the problem of the aging farmers. So we find out that now the community have resorted to other means of securing their food security. And so the objective of the project is to support the farmers around the Bosomtwe landscape. They have about 2 districts, the Bosomtwe district and Bosompraha district, and about 95% of the community are into farming. So we will support the farmers around the lake Bosomtwe landscape to become self-reliant and secure climate change, resilient and mitigation. Yeah. So the project will be done at the agricultural landscape around the lake, and it's for 20 months, and it's being sponsored by Expertise Funds. And the target group will be basically the smallholder farmers, and then we also some volunteers made up of the community-based organization around the lake, and then the district assembly. We also consult them, and then the AES in the area, they will be their main target group for the project. And at the end of the day, the final beneficiaries will be the 24 local communities around the lake. So the main activities that we'll be performing is building the capacity of the farmers. So we are going to train 80 farmers and then the 20 volunteers made up of the community-based organization around the lake. The local government, we train them in PISCA, it's participatory integrated climate service for agriculture, and then the climate change adaptation and mitigation practices. So what we'll do is we'll first have a meeting with them, the farmers will be their leaders and then the AEs, and see how best, how best to select a climate change and adaptation mitigation practice that will suit their problem in the area, and then will also be good for the environment. That's what we are going to do. And then, based on these technologies we come up, we set up a demonstration course in the community so that the farmers will see how the technology perform in their community. And then other farmers who are not also involved in the project can also see and learn from it. And then we collaborate with the Ghana Meteorological Agency to provide us with historical climate data that we use for the physical training, and also so that we can have a system that during and even after the program they can still send information on climate information to the farmers so that it will inform their decision in their farming activities. And then after some time, with our technologies and with our training, we do a focus group discussion, field visit to see how the technologies are performing on the ground, and if there's a need to modify it, we'll do that. And then lastly, we'll look at ways to disseminate the technology to other places so that they can also adapt it. So CRI, our main role is to provide the training with the climate change adaptation mitigation practices. And then with some of the work we've done here, we look at the best technology for them. And then we set up the demonstration plots. We'll be in charge of that. And then we provide planting material based on our improved varieties we have here. And what they need, we provide them with the planting material. And then participate in the various workshops that the business reviews, what we participate, we do report writing. And these are the expected outputs from the project. We expect that 20 will train 20 volunteer trainers, 80 farmers, and at the end of the day, the 24 communities around the lake will be receiving climate data, and then at the end of the day, there will be increased farm productivity in the community. And then for IFSA 2 projects, I'll be working on for some time, and the institute have been performing basic an experiment on the aeroponic generated planting material. So for now, what we want to look at is how they perform against the farmers.
You have 3 minutes, please.
How they perform against the farmers' seed that you have on the market. So we look at the aim is to assess the kill performance of the aeroponic generated seed on crop management practices. That's exactly like locking, different side, we look at that. So the first one will be on the growth, looking at how looking influence the aeroponic generated seed. So it's going to be a scalable design, and the treatment will be, the main plot will be the source of the seed and aeroponic and the farmer's seed, and then we look at the milking without milking. We want just a simple experiment that farmers farmers can come around and appreciate how the hydroponic generated CBR perform against the farmer safe CBR. So this will be the list of treatment for that project. And then look at the set side I just have said. What the farmers normally use is the big set side from 300 to 500. So we chose 350 for that. We look at half of that and then quarter of that. And that one to the treatment, we look at aeroponic generated CDR, the farmers CDR, and the different set side. Okay, that will be the list of treatments. And then the third one, we look at the time of planting. So because we realize that now with climate change, the rainy season has changed. And then based on the amount of rainfall that the yam gets, and then how long it stays on the field, we have different results. So we look at early, we plant some early, and then mid. The mid will be the 30 days after the early, and the late 30 days after the mid. We look at how the organic generated CPM and the local yam they perform when we vary the planting time. So this is also going to be the list of treatment. And the last one, from the organic generated CD system and the hydroponic, we realize that we get more tubers from the system, from the greenhouse. So we now want to look at the different rates, how they perform. So based on what we have, we group them. So we look at the different size range of this of the microtubers that we are getting, and then we look at aeroponic, the one from aeroponic and the hydroponic, so how they perform, and then this is also going to be the list of the treatment. So these data will be collected. We will collect the vegetative data and the yield data at harvest. These are the list of publications, 3 journal businesses. Thank you.
Thank you very much. We are just on time. So I'll give you a clap. Hey, I didn't force you to accelerate, but all right. Shall we now invite Dr. Patricia Chapo? Can we give her a clap as she comes, please? I thought you were cruising well. All right. Look, if there's going to be any further delay, we will now enter into the question section because the next question will be the continuation of Pharisee. Then we can sort out the issue.
Yeah.
Yeah, okay. All right. Okay, good. Thanks. Thank you.
What is happening with the pen drive and the laptop?
All right. And these things will happen. Thank you.
RCM division. So I'll be presenting on 2020 activities, success story, plan activities for 2021, and then publications. So the first activity is on usual food. That one, I worked on a title called Gender and Yam Production in Ghana. And the team, myself, Prof. Queen, and Mrs. Opoku. The objective for that research is to assess the roles of men and women in the yam production system, to evaluate access and control of production resources, and to provide feedback information to policymakers to assist in integrating gender in yam production. So we had this methodology. We worked at Bono East and Northern regions, and we collected both qualitative and quantitative data. So results, demographics, comparing the females and the males, we could see that the female yam farmers were older than the male yam farmers. And then on education, the male farmers had more education than the female yam farmers. So going to on the rows, in fact, you will see children here. But I want to draw your attention to the fact that we collected intra-household data, not only on the male and the female. So the children here is referring to those children that are old enough to help their parents in the farm. So for these activities, we can see that males performed most of the activities, even though females were involved in some of the activities, but males' involvement were dominating in most of them, from land clearing to marketing. Access and control of resources. Women from the south could access and control land through inheritance and leasehold. But in the north, women could only have access to land and control land when their husbands died and bequeathed land to them. There, the women could not lease land or purchase land, especially if they are married. And then the men had more access to labor than women for farm operations. So maybe that was why that graph, men were so much involved in the production activities than females. And then when it comes to finances, the females are lacking over there. And then I'll go straight to some constraints. Constraint to young farming. This one is in order of, should I say, ranking, the first, second, third, and then so on. So the men rank pest and disease damage as their number one constraints, and then the women talked about labor. So when you look through, you can see that the rankings of men and women were quite different. So in conclusion, I would say that land clearing, sand bed preparation, planting, staking, and seed treatment to harvesting are mostly men affair. And then women are involved in planting, weeding, mulching, staking, and marketing. Land tenure arrangement is a problem for the women, especially in the north. And then the constraints, in fact, I picked some few ones for us gathered here, because I am thinking maybe we could do something about some of the constraints, especially the planting material availability. They don't have to the improved planting material. So they keep on getting low yields. And then the marketing too. Maybe we can come in by educating them. And then the land tenure with these platforms that we've been forming all around, maybe we can use that to influence that system a little bit. And then the pests and diseases, and then poor storage. I think we have the capacity here to help the farmers. So I'll go on to talk about PABRA activities. That one I worked on gender perception on climate change indicators. And that is the team. The objective of the research were to assess men and women perception of climate change, and also to assess men and women adaptation measures. So the study was carried out at Atebuamantin and Edras municipalities, and we collected primary data using structured questionnaires. In fact, this work is ongoing, so I will just present some results, some preliminary results. So looking at the graph here, and looking at the levels of perception that the males and the females had on different climate indicators. On the rainfall, we could see that both the male and the female from Edra Atebu, I think it was at Atebu that farmers felt that climate change was actually a problem. They rated that very high. But for change in temperature, they said, okay, yes, there is change in temperature, but it is not that high. So for the effects, the climate change effects, the climate change effects, you can also see that most of them, almost all of them rated that as well, moderate. So here, I concluded that males and females have moderately high perceptions about climate change issues. So they need some sensitization about what is going on. And then I'll touch on the mentoring program. I'm very passionate about this because the program is doing so well and people are benefiting. So I highlighted some few things there concerning publications and then conferences. And you can see that those involved in the program are doing very well thanks to our mentors. And then the director who is pushing so hard for us to have this program move on. So 2021, I'll be working on PABRA projects. Okay, let me mention the topic, a very interesting research topic here under PABRA, youth transition to adulthood and agricultural involvement. So that will be the research that I will undertake under PABRA. And I'll continue the analysis of the climate change perception and adaptation studies. I would have to employ some models to actually see the relationship, what is going on with what we saw. I'll also continue the mentoring program. We will end the phase 2, and then the phase 3 will start bringing in more people so that they too can benefit. And then I'll be writing proposals and helping in technology dissemination activities, especially with the PABRA projects. These are some publications. Thank you very much.
Thank you very, very much, Dr. Shadi Bekla. You can also believe himself that the division from or more time. Alright, shall we get our team up there? Our presenters, please, shall we move up there and let's quickly take our questions. All right. Thank you very much. Okay. I'll learn from this gentleman who just left. But I'm going to start from here. Can you? All right. Okay. Doc. Young man. We'll be playing like a man.
Dr. Jonas, please, so far, how do you assess the impact of the innovation platforms you helped to establish? Dr. Olusi Dankwa, Chief, do you have any information on the performance of the follow-up crop under the two regimes? The regimes here are where PGP was fertilized and where it wasn't. Thank you.
All right.
Thank you. My first comment to Joyce. In your earlier presentation, you were indicating that orange flesh sweet potato was gender friendly. Then, getting to the expected results, you were saying that you want to look at how sociocultural characteristics hinder adoption of the orange flesh sweet potato. How do you reconcile that too? Then, Madam, how the last presenter?
My friend, which of the madams? Is it Dr. Echempo?
Thank you. You were saying perception of temperature attribute as a climate change indicator. They say it's a perception of temperature. How do you measure perception of temperature? And youth transitioning to adulthood. What is the age range to transmogrify from youth to adulthood and their involvement in agriculture? Because now we
have transition.
youth in agriculture. Thank you.
Thank you. Yeah, okay. The parts and then Mr. Wachi.
Thank you, Prof. My first question is to my HOD. In stating your challenges, you said we were short of agronomists. But I know that recently there have been some transfers of some of the agronomists from the division, and now we are short. Please, what do you intend to do about that? Because you have identified the shortage as a problem. Are you going to get our agronomists back? My other question goes to Dr. Oshidanko. I quite remember there were problems with grazing of the PGP by some farmers at the outstations where you planted them. If you intend to roll out this technology to the farmers, how do you intend to overcome these challenges in the future? Thank you.
Right. Mr. Wachi, you have the floor.
Dr. Jonas, you have a rule.
Dr. Edu.
Dr.
Oseyedu. Dr. Oseyedu.
Dr. Jonas Oseyedu.
Okay, that's correct.
Yeah, you talked about
promoting partnership with the private sector. What can you do, or what role can you play as far as commercialization at CSIR is concerned? And the second one is, what are the main challenges as far as CSIR TV is concerned? And how can we surmount these challenges?
All right, okay, if there is none from here, shall we?
Thank you very much. HOD, you said you're going to use a multi-stage sampling method. Why multi-stage and not the others? Dr. Jonas, are there plans to include other commodities in the third program? Because so far it's only maize. And you said you're going to do some work on standardization. We didn't. I think this year also, what are you going to standardize and how? And what steps will you take to expand? You said you're going to expand coverage of the CSIR TV. Locally, we are even having challenges. So, what steps will you take to ensure that? Dr. Eric Dankwa, is there any varietal differences? I mean, how did you arrive at the varieties? I hope you're getting the point. Dr. Patrick Champion, one of your specific objectives was to provide feedback to policymakers. Have you done that from your side?
Okay, but something. Just a comment. Just a comment. In your mention, I think we produce a table. I'm not so sure whether you were telling us about improvements after the mentoring session, those things that improve. I saw something like published publication. I think we need to correct that. Either improve rate of publication also, if you want to put it better. I just saw published publications, which is, I don't think it's right, so correct it, maybe improve rate of publication. Okay.
Thank you. I think this group has done very well in terms of our they have contributed so much towards the upliftment of our institute, publications, donor funding projects. You've done very well. Thank you. HOD, thank you. Need space for National Self Personnel and NAPCO. We'll look into that. I assure you. That one, no. This one is for Dr. Champon and Mavis. I think you have done very well in the mentor-mentee program. And we have discussed this at DMC, and other sister institutes have really taken it. So they are learning from us, so we should do well in bringing innovations into that. And one thing I want you to know is you have so far concentrated too much on the research staff. I want to know if you have plans to bring other people on board, especially the administration and the other category of staff. And then maybe it's in your 2021 work that you have proposed to do, I saw something like you have proposed 6 treatment combinations, but you did not tell us what are these combinations so that we can help you to do things right. So we want to know these 6 treatment combinations you are proposing. And then, Jonas, thank you very much. I thank you and your team. You are projecting the institute so much in terms of visibility with our TV. And I also want to know, how do you intend to commercialize this TV program to raise revenue for us? And lastly, CSIR, the head office, wants to take over the TV station. What is your take on that?
Right, thank you very much, Dr. Osedu. With respect to the IPs, some were established under the upstate. How many of them are functioning now? After the fire. And I also want to commend you for the hard work that you are doing. I mean, that's my small room there, and I see the place is always active. All right. Congratulations on your PhD. You have a beautiful campus. I was there in 2018, Michigan State University. Congratulations. May, you said that at the lakeside, because of the climate problem, the community have resorted to other means of ensuring food security. Can you give us an example of one of the other means? And there is an odd request. Maybe, Director, I'll just request from you. Now, one of the presenters wants to ask a question. So I'll just give that opportunity if you allow. My HOD, you want to ask a question, so go ahead and ask a question. I don't want to be rebuttal.
Thank you, Mr. Chair. My question goes to Eric and Mavis. In fact, Eric, about the PGP, how is it culturally accepted in our system? And then Mavis, with the lake, recently there was a news that some place has been cleared and, getting towards the lake, and it's infringing on so many, the growth of the fishes and whatever. How is your program going to address some of such things if maybe where you are working, it's close to where the place has been cleared? That's the question.
Right, go ahead. Yeah.
So I should respond to mine.
All right.
Mr. Jobeku, yes, the literature says that sweet potato is female friendly. And so the study will really want to look at the gender differentiations and then to really confirm its gender friendliness. And then after that, we will make the recommendations so that in adoption of technologies or of the technology, and it will be in general, we will know the gender differentiation and then how to address those things so that we will be able that our technologies will be adapted effectively. So that is pardon me.
Look at the expected result.
Okay, I'll look at it. Okay. And you are part of us, and I don't think that the internal transfers are going to be revoked or they are going to come back. That is why we really need some more agronomists if we really want to maintain our resource crop management section of our division. We really need more agronomists to work with. I realize that it is really something that maybe the whole institute will have to think about it in restructuring things. Because I was listening and I realized that some divisions already have agronomists. Some other divisions don't have. And we had the majority of agronomists, and then now 3 of us have gone. So, are we going to sort of get more agronomists for each division, or get for our division so that we maintain the crop resource crop management part of our division? That one, I think IMC will have to look at it, and then director has assured us that we will look at it. So we will still need more agronomists. Thank you. And then Prof. Hans, multi-stage sampling. We are doing multi-stage. We are using multi-stage sampling because we are looking at different regions and then districts. So the regions are purposely selected because they are into sweet potato production. The districts will be randomly selected, and then coming to the farmers, they will be purposely also selected because we want to get those who are actually growing the orange flesh and sweet potato. So that's why the choice. Thank you. Mr. Pierre, you asked how I measured perception. Temperature. No, it's perception on temperature change. So, am I okay now? Okay. So, maybe the way I put it. So, it's perception on change in temperature. And then you also asked about the age limit for the youth transition in agriculture to adulthood. In fact, this is a new research that we are going to do, and like you are saying, we really don't want to peg it at the youth full age for the 18 to 35. So, in fact, the work is mainly qualitative work. So, with the different localities that we have chosen, when we start, I think we will be able to know who is a youth, and then the dynamics will come in. That was why I said it's going to be a very interesting study. So, for now, being a youth in the Ghanaian context is from 18 to 35 years. And then, Prof, you said I mentioned to provide feedback information to policy. But if you noticed, when I was presenting on YAM, those parameters that had policy implications, and I thought it could be somehow solved by us, I brought them up because we are all policymakers. Yes, we are all policymakers. So I brought those up so that some of us could take it up and help in a way, in our own small way.
Maybe I didn't understand you that way because I felt that as an institution, you have carried out a study, and then we're going to, maybe the director will meet either the LIAD or the minister and say, okay, this is what we have found. So that should inform the next policy we're going to make. That was my understanding.
Okay, and it is part of what you are saying.
So I am sure director picked up some few parameters that have policy implications. And
I want you to help me. So that is why I said,
yes.
what do you want him to discuss?
Oh, okay. So director, please.
Maybe you can tease it out.
Yes, I will do that. And director have to sit and talk about it because we cannot have so many people on a program at a go. That is why we have it in phases so that we
Not so many people.
yes.
But I'm saying that we have so far concentrated on the research staff. What about the other categories? Yes.
Okay, we'll think about that. I think that's
fact. I made a comment. Did you accept it?
yes.
You didn't comment.
I didn't because you said it was a comment. Okay, that was in fact the title was summary of output. So I think it should have been publication, number of publications. So I have taken notice of that.
So the rate of publication.
Yes.
More.
Yes. Okay. Thank you.
Thank you, Prof. Chair. We have a few questions. Dr. Osei wanted to know the performance of the crops, the other crops, after these treatments were put on the field. Yeah, this issue came to mind even when I started the study, because the title was also looking at sustainability. The sustainability need about 5 years, sometimes 10 years to be able to monitor what your soil is doing. But you know, as a student, I can't be on the field for such a long time. So with the inception of modeling, we were able to overcome this. We used modeling and then we calibrated using the 2 years data that I had. And I was also fortunate, MSU had developed a new modeling software called SALUS. So we used it, so as part of my thesis, it was there, and we realized that for 5 short term and long term, 5 to 10 years, these treatments that were on the field is able to sustain their own productivity. So we were able to overcome this with modeling. And then the issue of pigeon being raised by livestock. As for the issue of almost every crop in the field is a sort of food for livestock or most animals. But the issue of this issue can only be addressed through policy. Because in my case, these were Fulani cats who went into the field, right? And if policy doesn't do anything about it, even if you had your maize, cowpea, whatever crop you have, they will still go in there. So this is a policy issue. And once the Fulani issue are addressed, the PDP can be grown almost everywhere and there wouldn't be any challenge. Then Profans wanted to know if there are varietal differences. Yes. There's a short duration which is 3 months, and a medium 6 months, and a longer duration which is about 8 to 12 months. But in the PDP young cropping system, you are interested in the biomass. And the longer it stays on the field, the longer you get more biomass, then you can also get good sticks for the sticking of the yam. So in this case, what we used were local varieties which were longer duration, and we were able to get the sticks and the biomass. But I'm in touch with Dr. Adi Legumes to discussing with him if we can look at bringing in germplasm so that we look at in this PGP young cropping system, if we can get more erect stems and then also get by assertions, we can produce more biomass. It will be a plus. So once, and it all comes down to funding issue. So I'll discuss with him, we will look at working on funding. If we get funding, we'll bring assertions from ICRISAT and other international institutions. We will screen and then look at what works for the PGP young cropping system. Then my HOD wanted to know if it's acceptable, culturally acceptable. I would say yes, because Edra
Atebubu, Kentampo, they are already growing this, and they have local name. They call it Ebua. Yeah, they grow it, but just that they don't grow it with yam. And I'm looking at bringing this together so that the pigeon tree can facilitate yam productivity. So already they are into it, but we just have to help them so that they can bring it together. I think I'm done with the questions that I have.
Director, your question is, I think I didn't get time because of the time to go through the treatment really well, the factors in the treatment. So like the different CSIR, I'll be looking at CSIR, which will have 3 levels. What the family used, that was the 350, half of that, and then 1/3 of that. And I'll also look at the source of the planting material, one from the aeroponic source and the one from the market. So that would be 3 times 2 to get the same treatment. I think that I didn't get time to go through the factors and the levels very well. And that Dr. Page, what I really meant was that they resorted to different means of like when you go there, they are now to buying and selling. Like, they have instead of farming because they are getting low yield. Now they are most of them are into buying and selling. You realize they are just there. Some have also moved out of the community. So that's basically what they are doing. Instead, because they are getting low yield, they resorted to other means. I think that's what I meant. Like buying and selling, the youth are just not doing anything. They are also doing trade other things. And then HOD, yes, I saw the news on TV3. So I think we are now about to start our work. So what we will do is to involve the opinion leaders, the chief, and then the district assembly. They are one of the target groups. So we involve them from the start so that they take the project seriously. And then we also include for the agroforestry aspect, we include fruit trees. So I think once they're able to benefit directly from it, they will watch out and make sure that what's happening doesn't occur again. Thank you.
Thank you very much. I think I had the most questions, so let me try this. I'll start with Dr. Kinsley. In terms of the impact of the IPs you've been establishing, I must say it has been positive because as you saw in my presentation, one of them helped them to get access to credit. There are others through the IP, they have access to seed and other things. But the challenge has to do with sustainability. Once the project ends, you go back and functionality goes down. So what we are trying to do with the new ones that we are working on is to improve the governance structure in terms of the leadership and other structures, such that with or without projects, we will still continue. We are not able to monitor the IPs because once the project ends, you have no means of going back to the field. For example, take WAP, you take KC, all the IPs we established at those ones, we can only get in touch through mobile phone conversation. So it's something that we need to think about. Is it a way of institutionalizing this so that even after the project ends, CSIR can take over or something? Now, with regards to PRO, you said what role can I play as far as commercialization is concerned? I can provide technical advice in terms of what best business model we can adapt. And I have already started doing something as far as the agricultural productivity training center is concerned. That's why I talked about short trainings. We hope that through these trainings we'll be able to generate some income. We partnered with the former work coordinator and we were able to bring in 13 countries with about 26 participants. And I think if you continue on that path, we can improve. We're also working on having an SMS alert system, as I said, that can bring in a lot of money if you're able to partner with the telecoms. Because once the person speaks on the line, you'll be charged and then we can have our parts. So that's what I can do as far as commercialization is concerned. Then you wanted to know the challenges of CRIT. There are basically 2 folds. As I said, personnel and then equipment. We are doing this on voluntary basis and as a result of passion. But you and I know that TV work goes beyond that. So if you can get 1 or 2 permanent people, that will help. Also, we are appealing to all staff who have the passion to join so that we can share the workload. you see me directing, you see me going up and down. So that's the challenge that we have. Equipment. Yesterday, if you realize we're using mobile phones at a point in time to cover. We need powerful cameras, we need microphones and other things. So once we're able to surmount this challenge, we are good to go. Now, to Prof. Hans, are there any plans to include other commodities in the PEG program? I'm sorry to say no, because the project came from CORAF and they decided that we should focus on maize and rice. Maize for CRI and then rice for SARI. So unless we get another opportunity again, we cannot change that for now. Standardization, yes, you are right. It's one of the issues that have come up from PEG, MAC, and other projects. So under PEG, we intend to hold dialogue sessions with the district chief executives to see if you can pass on local bylaws to protect the farmers. We did that under OSAID, but after some time it broke down. So we want to go back and see, can we lobby the district chief executives to have that bylaw back. You were wondering when I talked about expansion of CRIT, that even with the current we are struggling, you are right. That is why I brought up the challenges, knowing very well that management is here, project leaders are here. They will come to support us, and with their support, we can now expand. Now to director, how do we hope to commercialize CRIT? The first step is to have very good content, and that is why I talked about we coming up with some content to add up to what we already have. Once we have very good content, we can have people to run adverts. Because the people will only bring the adverts when they know that more people are watching your channel. So once we need to create very good content, be consistent. Now we load a story and 2 months, nothing is online. That is not very good. But usually maybe every day we need to put 2 or 3 stories. Then people will come online. Because TV is making a lot of money and we can do that. With the politics of CSIR taking over, it's a dicey issue. As you know, we had discussion with the DDG, and he has set up a 3-member committee to look into that. Myself, the head of corporate affairs, and then the MAC commercialization, I think no PR. So there are 2 things they are looking at. But they want to take over completely so that we become CSIR TV. But we are not for that. We are suggesting that if it's possible, they should let us maintain the name and support us with equipment and logistics, then we can expand our coverage. But they want a total takeover. So that discussion is still on the table. So my stand is, I'll prefer CRI still holding it because we brought it up. And then they support us. But if they want to take over completely, then there should be negotiation for us to benefit in terms of copyright. Because it is our baby and we must benefit from that. Prof. Betty wanted to know in terms of the OSAID IPs, how many are still active? I can say 2, Amantin and Atebubu. For the North, I've lost touch with them for some time, so I'm not able to speak to that. Thank you very much.
All right, okay, good. Yeah.
We shall give a clap to the group. If you can listen now. All right, we now have a large batch, just about 5 people. I don't know whether Shaq is around. So look, come take over and let's see how we can. Thank you, Professor Betty. That's a good one. Thank you. Please, can we just we invite the presenters for the last group for the day. It's Mrs. Abigail. Here, Abigail, are you here? Yeah. Okay. So please, it's 10 minutes. And if it is 10 minutes or if you are not done, I'll stop it.
afternoon. I'm Abigail Adanso with the Resource Project Management and Social Economics Division. This is the content of my presentation. I'll take you through my research activities and what I did last year, what I plan to do this year, and also present my publications. Well, this is a research team I've been working with. For my first research activity, and this is on live bamboo staking for young production. And it's established that staking is important for young production. And based on the staking method used, it can improve or increase yields on young. It can also cut down on based on the method, it can increase the yield production. But we also know that the staking methods can be expensive. It can be laborious, and also depending on the method you use, can even contribute to deforestation and forest degradation. So based on this research was designed to integrate bamboo, which is a very fast-growing plant species, into young production to make the production system more, to make it more resilient and climate smart. Now, we are trying to say that advantage of the many qualities of bamboo. For example, bamboo is known to be the fastest growing crop on earth. And due to that, it's able to sequester or has a high carbon sequestration potentials. And also, it can improve soil fertility. So, if we include bamboo, integrate bamboo into young systems, we know yam requires a lot of nutrients. So if we integrate live bamboo into yam production, we can cut down the cost on use of fertilizers or also cut down on the need for, sometimes the farmers go into the forest to clear lands for fertile lands to plant, so this can be cut down. And also, if the farmers have the bamboos integrated on their farms, right on their farms, there wouldn't be the need to look for or to purchase staking materials, so costs will be cut down, and costs involved in transportation can be cut down. So it comes with a whole package. So specifically, we are looking at the trial. This trial evaluates the effects of live bamboo staking options on the growth and yield of yam. We will evaluate the effects on soil quality, because it is also established that bamboo can replenish soil fertility. We will try to see how economic viable this process will be. And lastly, in the last year, we are planning to run it for 3 years. So in the last year, one of our activities will be to estimate the amount of carbon that the live bamboo yam system is able to sequester. So we will use the plot has already been established, so we use randomized complete plot with 3 replications. We are using 3 treatments. The first is a live staking one. We are using the bamboo species Bambusa vulgaris. It's an indigenous bamboo species, and that's what you normally see around river banks and around the roadside. Those are very common bamboo species in Ghana. And the second is an exotic species. It was introduced a few years back by the Forest Commission and trying to promote its use in the country. Then the third treatment would be what normally our local farmers use. They go cut the bamboo stem, so they have the dead, doing the dead staking method. And we've already established it here at Omesa. So on the field, this is how a live stake plot would look like. We have, sorry. Sorry for that. So So these are the state plot. Each state plot will have 3 rows of bamboo. Uh, 3 rows of bamboo. And in between that, we have the yam ridges. So the plan is to train the, so for example, this yam ridge, the yam cell will be trained onto the bamboo, and this also be trained. And this also be trained on this and that and doing that. So for last year, what we did was the bamboos were planted in the last quarter of 2019. And the plan was to introduce a yam last year, but we couldn't due to some few challenges. So what we did was to manage the field. Then because the Bambusa vulgaris is an indigenous species, it's become well established. But we had problems with the exotic one because of the inadequate, we had to go make some refilling. And we also had to do some watering because of the lack of rain. So we couldn't introduce the yam last day. So these are some photographs from the world. The first is we had a thinning operation for the vulgaris, which has already established. And the second picture is during our replanting, we have to do some watering. So currently, this is how the state plot looks like. So for this year, what we plan to do is to continue management of the field. We have to do some thinning and canopy control because you can see that the bamboo, something specific to be an aggressive, very vigorous plant. So we have to do some canopy control and also thinning so that we can get our yam in there. And for this season, I said that we are planning for 3 years. So we will introduce our first year yam this season in a few weeks to come. Then we start with observations and take our data on soil, the growth and the health parameters. So this is my second activity. My second activity, actually 2 trials in one. This one is also looking at the influence of bamboo cropping on soil fertility and the growth and yield of local and improved varieties of cassava and maize. This is being done in collaboration with the International Bamboo and Rattan Organization. It's actually a part of a bigger program where they are trying to encourage farmers to include bamboo into their system to make their farming operations climate smart. So the objectives are to evaluate the growth components of a local and improved variety of maize and cassava. So there are 2 trials, there are 2 fields are set up. The second will be to evaluate the yield of the local and improved varieties of the crops, and also to look at how economic viable that would be, and also to evaluate the effects of the bamboo cropping also on soil quality. So we are using split plots with 3 replications, and the plots have already been set up here at Commercial. On the field, so this is how it looks like. If you take, for example, this plot is a bamboo plot. So it will have 3, it will be bordered by single rows of bamboo planted at 4 meters. And so each plot will have 6 stands of bamboo. So for last year, we planted the bamboo in the second quarter. We planted bamboo in the second quarter of last year, and we continued with the management of the bamboo. Then during the third quarter, we planted our first season cassava and started with observations and data collection. This is also some photographs from the activities we undertook. For this year, what we plan to do is to continue with observations and data collection on the first season cassava. Then after harvest, we plan to go in the second season cassava and start with the data collection. We couldn't do the maize last year, so we are going in for the maize trial. We will have the first major and minor season maize crops this year. We also do the observations and data collection. If all this go well, we plan to have farmers to invite farmers to come and see the results of our first year's activities. So, on my publications, these are the publications I was involved in last year. And this year, I'm considering two publications. One has already been accepted with manual revisions, and the second is also under preparation. Thank you for your time.
Thank you. Let's appreciate it. Thank you. The next presenter is Mrs. Mary Jose Asante. Well, let's appreciate it. You have 10 minutes, please.
Thank you. Good afternoon to you all. Good afternoon, directors. I'm presenting on what I did 2020 and my planned activities for 2021. The activities I carried out in 2020 were 3. Confirmatory trial and adaptation of travel to different landforms, which Cynthia has already spoken of, and the assessment of the accumulation of heavy metals due to inorganic fertilizer application on cocoa. That one too she presented on because we continue this year. I'll be presenting on maize soybean cropping system for sustainable production. I'm using the straight crop model to see how we can produce sufficient quantities of maize and soybean in Ghana. And this is how last year's field looked like. Last year, we had some results, and it's interesting. I'll be commenting on the no fertilizer. Maize 1 is maize with the intercrop of soybean. The soybean 1 is the intercrop of soybean within the maize plot, and the sow maize plot and sow soybean plots are also there. We realize that even with no fertilizer, but with soybean intercrop, we are getting the maize yield of 6.5 tons per hectare, whereas soybean on the same plot gives us an average of 1.3. So if a farmer even do the intercrops, this is what the story will be told. Again, we incorporated poultry manure as part of the treatment NPK and the poultry manure NPK combinations. Because I'll be repeating, I'll tell us the details later. This is last year's result showing that poultry manure significantly affects even sow maize crop as well as the intercrop and soybean as well, giving us 1.6 tons per hectare of soybean and 7.4 tons. This may seem to be too much, but that is the reality of what was obtained. That's my research team. Why am I interested in the maize and soybean? The yields are lower, as we can all agree. Currently, IFRI report tells us it's still at 2.5 tons per hectare for maize, and soybean is hovering between 1.7 and 1.8. But in all our research fields, we can go as high as 6 tons for maize and 3 tons on the estimate for soybean, depending on the variety. Now, this year, we know how important maize has been, likewise soybean, because of its scarcity. And 75% of the total production in Ghana is used by only the farmers, the poultry farmers. How much do we need to eat? So this year, even KK's price has risen from 1 cedi to 2 cedis. That makes maize very, very important for us to work on, as well as soybean. So my objective is to develop a functional maize soybean cropping system to deliver sufficient quantities as well as good quality maize for the industry and food security. In addition to assess the soil status and that cultivation over a 2-year period. as I said, adapting the maize soybean strip cropping model. So I'm using a row spacing of 40 centimeters for the soybean and 60 by 40 for the maize. This looks or seems to be closer. This has been adapted elsewhere and is working perfectly because we have now bred short varieties that does not need larger spacings, 80 by 40, 90 by 40 as we have been doing previously. So my treatment are my soil-based plots, soybean, and the intercrops. For the fertilizer treatment, I'll use 2 tons per hectare of poultry manure, then NPK as recommended, and a combination half each of the poultry manure and the NPK, and my control will be no fertilizer. I'm using the split plot design with fertilizer levels as my main plots and the cropping arrangement as my subplot. I'll be collecting data on the soils, NPK and C, as well as pH at the end of each season. Then the crop parameters will be measured, including the nodulation of the soybean. This is my expected outcome at the end of the period. This is to increase the crop yield per unit area for both maize and soybean, and also to improve the nutrient status at the end of the second year. I must say this is how the plots information looked like last year. This is a picture from us, not from a foreign country. The maize were good, the soybean were also good. That's my list of
Hello, this is CRI TV
Thank
Beyond
you
the
so
Research.
Thank you very much for saving some time for us. Thank you. So our next presenter is
Hello, this is CRI TV Beyond the Research, and this is the maiden edition of Women of Science. I have here a noble woman who is going to be our guest for this maiden edition. Here in Ghana, mention GMO and her name follows. Mention biotechnology and then you see her name again. And she is the Deputy Director of CSIR Crops Research Institute. And she has a tall list of many achievements. I don't want to go on with many other things that are related to her, and that's the reason why she is here, to tell us more. Her name is Professor Marian Dorcas Queen. Prof, you're welcome.
Thank you very much.
Welcome again to Women of Science, and this program seeks to celebrate women who are making waves or making strides in science, and is to inspire lots of young women or other women who are trying to give up in their journey of science. So welcome once again.
Thank you very much.
So I have mentioned your name, but we want to know, who is Professor Marian Dorcas Queen?
I would say Marian Dorcas Queen is a research scientist who has a passion for science. I've been working in the field of tissue culture since my BSc in 1988, 89, finishing. I graduated in 91 from the University of Ghana, Legon.
Wow.
With the botany department. I was mentored by Dr. Elizabeth Champon, and I owe her a lot in my expertise in tissue culture. She's the first person who ever taught me tissue culture, and I really appreciate. So, in a nutshell, for my beginnings from BSc, that is what I would say.
Okay, you mentioned the Department of Botany, and that's Legon, the Premier University. I realized that your BSc was in Botany, MSc Botany, PhD Botany, and in chemistry, one would say this is aliphatic, a straight change. What is so fascinating about you and plants? We know botany is the study of plants. What is it about you and plants?
Growing up, I knew I liked fidgeting with things, and I would like to do research. My father wanted me to be a pharmacist, and he first wanted me to do medicine. I told him I can't face blood, human blood, and I can't fidget with humans, so I need something I can handle and turn around. So the other thing would be pharmacy, and that would mean playing with medication for humans, and that could also be a bit uncomfortable because maybe you lose some lives before you finish designing your drug. And I was privileged to have been offered sciences at the University of Ghana, Legon. And so I read zoology, botany, then first year it was physics and chemistry as well, and mathematics. So second year I majored in botany with zoology. So my degree is actually botany major, zoology minor.
Okay.
And that is how I came into zoology, botany with zoology. And my project work was in plant physiology. So typically I'm a plant physiologist.
Okay.
Just that I've used techniques in tissue culture for plant improvement. And then going forward, I've added on molecular biology and biotechnology.
Okay. So every child, when asked, what do you want to be in future, has something to say. But you first mentioned that your father wanted you to be a medical doctor, and then another option was a pharmacist. So what was actually on your lips talking about what you wanted to be in future? Was it something centered around science, or what was it?
My father was a zoologist.
Okay.
He was into poultry farming.
Okay.
And my mother a nurse. And my mother told me that I would be a bad nurse.
Why?
I don't know, because she's a typical nurse, and maybe the way I handled myself, she told me I wouldn't be a good nurse. So at the back of my mind, I knew nursing wasn't I wasn't going to go into nursing. So in fact, when I was entering the university, they asked me whether I wanted nursing or sciences, and I said no to nursing. I want the sciences. So growing up, I knew I wanted to do something that I could play with. Something, yes. So I knew, growing up, I knew I wanted to go into science.
So even when your basic school teacher asked you what do you want to be, what were you saying?
Those days they wouldn't ask you, they'll tell you have to be a doctor.
Oh, okay.
So coming up, and when I got to know what it entails to be a medical doctor, I knew I wasn't tailored for that.
Was it because you were always first in class or among the first three?
Of course, I was always first in class, from class 4.
Okay.
I was first in class till I finished class 6. I completed.
And which high school were you?
I was in Infantman Girls Secondary School from Form 1 to Form 5. Then 6th form, I did my 6th form with the Wesley Girls High School.
Okay. So any awards in these schools?
I was a very reserved person. If you ask me to take a position, I would ask you to give it to my friend. So I was very reserved. So those times I didn't really come out. It was in primary school that I had award. In primary school, I think in class 6, I won the Central Region mathematics competition.
Okay.
So my name was in the papers.
Oh,
The Ghanaian Times.
Okay.
I can't
I
remember the page,
remember.
but I know it was in 1979.
Wow. Revolution time.
Yes.
All right. And then in secondary school, no award.
Secondary school, we were not really having speech days those times, so I didn't take any awards in secondary school.
Okay. Okay. So yes, as you said or you mentioned, you were a reserved person, and if any position cropped up, you advise that it should be given to your friends or whoever. So as a deputy director now, and then before your current status, you have been a leader in various areas here in crops research. Can you tell us your story about this leadership group?
I would say, as much as I would give, when I was growing up, I was very introvert, if I should say. I realized it wasn't helping me. So by the time I got to the university, I had really changed. I had really grown. I went to the university, and my mates from the sixth form were asking what had happened to me. And I think I had suddenly woken up from a slumber. I had woken up from a slumber.
And you don't actually remember what situation stacked up?
I would say it was because my dad got sick.
Okay.
And because I took a lot of shadow. I was
so that
like,
it has enough airflow, and it also serves as a temporary storage structure for the produce that is being dried. So whether it's raining or it's shining, you can still have your produce dried with no problems at all, no droppings coming on your produce, and it dries very well. Now we want to be able to assess it. So there's an experimental setup we've done. I think OT talked about this earlier, and we are actually doing it. Split pot design with dryer conditioning. We are looking at opening the dryer completely or covering it halfway, and then see how it works as we dry the produce. And now, once we are done, we want to collect weight of the material to be dried, the grain moisture content, and then temperature and everything. We want to monitor all this. The seed quality assessment will be done, looking at the in terms of whether there's any breakage, any effect of the drying on the viability of the seed. So we do germination tests after the drying process has been completed. And we analyze the data and also report test of civic gallons to see what effect the dryer has on the various seed quality properties. And then on this note, I want to thank you and say that by God's grace in 2020, I had 2 papers fully published, and then 2 were one was published just last 2 months, and then this one will be published hopefully by close of this month. So I'll say I worked on all this in 2020. Some just trickled into 2021. So on this note, I say thank you very much for listening to me. As you give me a clap. Thank you very
Good afternoon. I'm Patricia Otidaku. I'm a soil and water engineer. Unfortunately, Engineer Shadrach didn't impress on us the importance of our ING. But in place of the ING, I can also put it as PEGHI. And when you see the PEGHI, it means that I'm a professional engineer with the Marine Mechanical Agric Division of the Ghana Institute of Engineering. So this is how my presentation is going to be like. I would give a few highlights of the activities that I undertook in 2020, what I plan to do in 2021, and my presentation, my publication, sorry. In 2020, we continued the Recirculate project, and it's a part of the Recirculate project, and that we are tackling rice and tomato. Dr. Iboa presented on the rice, and I have been working on the tomato. This is my team. We try to identify the physiological responses of the tomato crop to soil, water, and nutrient management under the partial root zone drying technique. Partial root zone drying is an irrigation technique where water is applied to only one side of the root zone of the crop. It's a deficit irrigation technique, and we are reducing water use by the crop. So we are subjecting the crop to some form of stress, and we are hoping that the crop will be able to increase or improve its mechanism to be able to withstand this stress condition and perform even much better than when it received the full irrigation amount. So we did 2 trials at Akumadan and at Umesha. Akumadan was the open field trial where we used 3 irrigation treatments: the conventional furrow irrigation, the deficit furrow irrigation, and the full furrow irrigation. Usually with partial root zone drying, you can implement this technique using furrow irrigation or drip irrigation or the half sprinklers, that is the 180-degree rotation sprinklers. So we decided to use the furrow irrigation since it was the least used around the world and the most cost-effective in terms of financial accessibility among others. Apart from these treatments, we also used 2 nutrient sources. The first one was the already known mineral fertilizers that we use, the NPK, and the other was the digestate. Digestate is similar to compost, but here we have other components like feces and other stuff all coming together to make up this digestate. And we apply this at the recommended nitrogen rate of the crop. So the greenhouse experiment was similar, but in place of the furrow irrigation, we were subjecting the crop to direct watering of these crops. But we split the bucket, as you can see over here, so that in case we are irrigating for example, the fixed partial root zone drying, you only apply the water at one part of this split bucket. So if it's fixed, we only apply the water at one part. For the alternate partial root zone drying, we still apply the water at one part, but we alternate every 2 weeks. So we apply water at only one part for 2 weeks, and then we switch the application side to the other side. So we took physiological and agronomic data as well as soil sampling, and we analyzed our data using GenStats. So here are some of our key findings. We realized that there were some significant losses when our water was reduced to 50%, but we were not alarmed because even though our water was reduced by 50%, we were having a compensation effect from the digestate that was introduced, and this effect was even more than what we were losing. Again, we can see that that would be for our APRD and FPRD. We also have some biomass reduction, but again, it was also compensated by our digestate application. For our fixed partial root zone drying and the alternate partial root zone drying, we couldn't see any significant differences between the alternate partial root zone drying and the fixed partial root zone drying. And this was good news for us because as irrigators, irrigation is laborious, and the more labor you take to do the irrigation, the more you are going to incur cost. So if you are saying that the fixed doesn't bring about any significant losses, then we would rather go for the fixed than the alternate irrigation, because we don't have that luxury of always going to the field to close pipes, open pipes, allow this particular pipe to flow or otherwise. That's why I'm saying that we were very impressed that the fixed was doing even much better than the alternate. So we wanted to also know if our partial root zone drying was affecting our biomass partitioning. And we can see here, this is for a graph for the field conditions at Akomadan, where we did not see any clear effect. But when we come to Fumeswa, we can see the clustering. That was giving us an idea that yes, there was something happening. So we went further to segregate this by the date. And then at 14 days after planting, where the treatment has not been instituted or implemented, we couldn't see any differences or clustering in our graph. But at 28 days and 56 days, we could have gone ahead to do for most of the data points or data dates that we had. And we could see some effects or evidence that prolonged PRD decreased water stress. And I'll talk about this later on. Oh, sorry. So when it decreases water stress, what is happening is that there is also an increase or metabolic activity that is increasing the production of a hormone of interest to us. And this hormone is called the ABE, abscisic acid. So once this stress sets in, and with the partial root zone dry, once this stress sets in, the signaling effect is that the plant is going to produce more of the ABE. And the ABE is a root to shoot signaling hormone, and it's going to inform the shoots to close the stomata, thereby conserving water. So this is also a drought tolerant mechanism that the crop builds. We had some trainings and capacity building activities. Even in the midst of the COVID, we were going to the field in our nose masks. So for 2021, we continue with our activities under the Recycling project. And we would also continue with a project that we started under PABRA last year, but because of drought conditions, yes, it affected us as well. Most people will talk about drought and they'll be looking at my face. It also affected us here. So we will continue with this activity where we are trying to explore some water harvesting techniques in situ, that is within the same locality, water harvesting techniques to improve the productivity of common bee. And we have identified the tide ridges and the banded basin that we are going to evaluate this year. We also had the grace of winning a proposal, a project in collaboration with the Bureau Hammond Energy Center at the KNUST. It's a 2-year project funded by USAID NAS. And it's agrivoltaic technology. What agrivoltaic simply means is that we are integrating food crop production with the production of solar energy using the photovoltaic system. So that is in effect what the agrivoltaic system seeks to do. And in our system here, we will be putting up this photovoltaic system. We will have 3 treatments to deal with. We will have the original photovoltaic system where we are not going to plant any crops underneath. And usually these systems are laid on the ground. Then we will have, yes, we would also have our agrivoltaic system where we will raise the panels to be able to accommodate crops beneath it. And that is how the system will be. Our crops of interest will be tomato, pepper, and onion. And with this same electricity that will be generated, we are going to use drip irrigation to irrigate our crops. And in the course of the installation, we will try and see if we can push the excess generated power back into our mainstream power to be used by our offices and other activities as well. These are my publications. I would like to acknowledge our director and the management, our donors, our collaborating scientists, our technicians. In fact, the NAPCO personnel, there is one of our guys, Austin, who has been doing marvelously well, helping us in all our staff. And I would also like to appreciate the technicians and full staff of RCM. Thank you very much.
Thank you. Thank you. Let's appreciate that. This is Monica. Let's appreciate it. We are going to Monica. This is like the
Thank you very much, Mr. Chairman. Good afternoon.
Good afternoon.
Thank you for the opportunity to present to you on monitoring and evaluation activities that I conducted in the year 2020. In my presentation, I will discuss the activities implemented, some achievements of some projects, the work plan for 2021, and some publications. I had the opportunity to monitor and evaluate some projects, which include Follow Me Well, Small Inclusive Productivity and Market Access, which is SIGMA project for maize and soybean value chain, Ghana Cassava Industrialization Partnership Program, and the Youth Swap project. During the period, I submitted quarterly reports to the director. I also contributed to the development of the CSIR strategic plan for the year 2021 to 2025. I was also involved in the drafting of a proposal on mainstreaming undergraduate students into biotechnology job market through hands-on experiential training in diverse techniques in plant, molecular tissue culture and genomics. And that was an SPBB, Plant Biology, Learning Objectives, Outreach, Materials and Education, which is called Blue grant. I contributed to the drafting of 2 manuscripts. The first was on awareness and adoption of positive selection technology among young farmers in West Africa, and this was submitted to the Journal of Social Economics. The second was on community awareness on changing gender roles in seed yam production, application for food security, an example of the community action in improving farmer safe seed, that is the K-Seed project. This was submitted to the Journal of Rural Studies. I also participated in Para advocacy programs. An example was a training that was organized for caterers on the use of common bean as a substitute in indigenous Ghanaian dishes. Some achievements of the Follow Me Well. This was a 2-year project which ended in 31st January 2020. The first objective was to determine appropriate synthetic pesticide for the management of the Follow Me Well. The target was to identify 3 insecticides and 5 were identified. The second was to conduct research to ascertain the relationship between Follow Me Well and local natural enemies and develop strategies to conserve them. The target was to at least identify 1 parasitoid and a pathogen, and 5 parasitoids were identified and 1 pathogen. The third objective was to evaluate the efficacy of biorational insecticides as alternatives to synthetic insecticides for the control of the armyworm. The target was 2 and 3 were identified. These were neem,
leaves and seeds, hibiscus leaves and jatropha leaves. These were used to prepare the bioinsecticides. The fourth was to put in place an early warning system for forecasting the armyworm outbreaks in Ghana. A model was developed. The fifth was to develop an integrated crop or pest management system to mitigate the armyworm. And an IPM module has been developed. In addition to that, 2 field days were organized to disseminate the technology to farmers, as well as a conference paper and a video documentary. These were developed on the push-pull system. Some few lessons that I would like to share with you from the project implementation. During our implementations, we realized that regular monitoring and review meetings that we organized regularly contributed to the flow of information among team members, and this led to the prompt schedule implementation. Also, farmers were fully aware of the damaging effects of the armyworm, but they needed the requisite technologies to be able to manage them in a safe and sustainable manner. These are some pictures that we took. The field day, one was organized here in Israel and the other at Nyampala. We also have the preparation of the biopesticides and some laboratory activities. This was the push-pull that was established at Israel and Teacher Pro. These are the team members. So if you have any questions whatsoever that you want to ask, you can contact them. That is with the technical aspects. With the USWA project, the objective is to establish functional, scalable, and sustainable public sector-driven commercial early generation seed systems for improved yam varieties. And we have outcomes, intermediate outcomes, and outputs that will go straight to the milestone achievements. We are to establish and maintain a fully functional temporary immersion bioreactor system within the institute to produce breeder seeds and planting materials. And these were those that were presented by Prof. Quinn and her team.